you're working actively in .NET and you want to learn more about how to use gRPC within our current stack. And we were wondering about that specific side. You'd be surprised because they created a gRPC infrastructure for their own requirements called Stubby, and it was meant to be used in the communication between their services. And this was quite long ago, in 2001, at the beginning of the century, in fact. So later on, around 2015, they standardized it by building a new version and releasing it open source. And this is the origin of what we have today with gRPC. And now, in fact, it's part of the Cloud Native Computing Foundation, the CNCF, alongside with other standards such as OpenTelemetry, Kubernetes, among others. Okay. It's language agnostic, supporting several languages and frameworks. So meaning that you can have, of course, one API written in .NET, another one written in Java, or another technology, and you can connect both of them without any kind of problem by using the same contract definition. Okay. And what features gRPC provides for designing such APIs? So, it uses a contract-first approach, the protobuf file, and binary serialization. Being a contract-first approach means that we define everything in a file called protobuf, where we define the entire contract, including models and services. And in relation to binary serialization, it uses protocol buffers to deserialize and serialize, doing it in an extremely performant way. It uses HTTP2 protocol as base transport, and that's one of the main reasons about its performance and capabilities, since it takes advantage of its header compression, multiplexing, allowing to use the same TCP connection to manage more than one request, bidirectional streaming, and binary framing, having then a more efficient and less error-prone service on paper. Allows multiple communication types, including one-way and bidirectional streaming. As we have seen before, it allows multiple communication types by taking advantage of the protocol, allowing bidirectional streaming as well. And allows providing REST API as well by using JSON transcoding. In .NET at least, it allows by using an opt-in package to expose already defined RPC services as REST APIs. Cool, advantages. It might seem redundant because by having shared its features, its advantages are somehow shared along with. But it's ideal for high performance applications, on paper of course. There are a lot of nuances that we can have into consideration. It's well suited in server-to-server communication, like direct inter-process communication between them. Shines especially when requiring high performance and low latency because of its performance and reliability, but unfortunately in JavaScript apps, at least running in the browser, might not be the best option since browsers don't support it natively, and the opt-in tooling to use it in these projects might not be as performance as we will expect. So it has its own special use cases, let's say. And again, we have shared a lot of time, but it's high performance in terms of bandwidth and size. Okay, so it shines because all that we have said at the end reduces the overhead in every matter: bandwidth, use, the latency, everything. And let's see what is our use case today, because we are going to present something technically speaking, and we will have two different services: one for films. Yes, I rather prefer the English term than the American one, and another one, the actor service, all of them with its own database. Then we have our UI with its own backend, having its own backend for frontend, orchestrating the different requests required for its own workflows, and everything included using traditional HTTP requests. Okay, so it's a very common scenario, very basic, but at the same time very extended outside there, let's say. And here in that specific part is where we are going to have our work today. We will be targeting our effort here, migrating this connection, this part of the connection, following the steps required to make this work, and seeing the capabilities of gRPC. We have to say that we have prepared everything using the entire .NET stack, but of course, the idea that we are presenting here today, it's valid for any kind of project. It doesn't matter that you're using Angular, React, Blazor or another technology in the front end, you can see that we are changing here at least the communication that we have between server to server, in that case between our backend for front end and our different APIs. Okay, so let's go. Let me here change and switch to Visual Studio. And let me stop sharing here because otherwise it will be bothering me in the taskbar. Let me open here as well. Okay, so what do we have here? As I commented before, we have here a complete .NET application. We are using, and you will be surprised because we are using .NET Aspire here. It is not part of this meetup and this presentation, but in any case, it helps a lot. It makes so easy to create an entire structure that we are going to use today. We are not going to deep dive on that specific part, but anyway, it's there and it's interesting for you to know it. We have our front end here. We have already discussed about that. So we have our backend for front end here is that server application. You can see that we also have some we have some endpoints here defining all the different workflows, all the requirements that we have for our specific UI. And our UI is a WebAssembly Blazor application, very simple to start with. And it's started from that specific backend for frontend. So we are hosting the WebAssembly application within the server side. Okay. More things. Then we have our backend here. Our backend, it's composed by two different APIs, the one that we were discussing before. You can see that this is a very flat structure, very simple, using minimal APIs. Both of them has exactly the same. So we have a program with all the different endpoints here defined. You can see that we are also using the client integration from Aspire here to define the DB context. Nothing special, only a different way to do it, and interconnected perfectly fine using all the capabilities of the telemetry and so on. But nothing that we are going to enter today. Of course, if you want a specific session of that, we can prepare for the future about .NET Aspire. And yeah, so nothing special, nothing fancy. We have here our models, some extensions to map from an entity to a DTO, our infrastructure containing the migrations, the DB context, and we have exactly the same structure here. Okay, for films and actors, we have exactly the same. What else do we have? We have these shared projects. These shared projects at the end are having the contracts, let's say. The contracts in that case are just DTO's models that at the end are shared between the backend for frontend and the APIs. Okay? So we will be targeting both APIs to add some gRPC services here. But let's check first that we have our database here. Also, let's check a bit the infrastructure. We have the database here. We have our actors database. If we inspect a bit the data here, we have some pre-populated data like actors here. We also have exactly the same for films. Let's inspect a bit the data. Okay, everything seems to be working. We also have some HTTP files here, so we can just try to invoke in an isolated way these services to check that both of them are working fine. Great, so we are retrieving back some films from here. And if we do the same here from the actors side, if we request here, and it will again also return some data from the actors API. So it seems that everything is working. Let's try to inspect it from the UI side. So this is the Aspire dashboard where we can see everything glued together, orchestrated. We have the APIs running. We have the backend for frontend running with the UI. So if we click here, we are redirected to our UI. It's not something really nice, but in any case, it's enough for explaining the use case today. So we can see that by using this communication, we are populating this grid. We can see some details of a specific film. We can also create one specific film here. For instance, we can say test, specify one specific date here, and register. And if we go here, oh, something has failed. What happened here? Let's see if it's in the database. If it's a problem about the reload, we can go here, films, view data. Yeah, it's here. It seems that there is some specific problem related to the refresh of the grid. Yeah, now it's here. Okay, and if we try to delete it, seems that it is deleted. Let's go here, refresh. Great, seems that it's working, despite the small detail related to the failure reloading the data once we registered a film in that case. Seems that everything is working. Okay. At the same time, last thing that we can expect here, if we go to the traces, we can see that we have some requests here, and we can see it's a very long, and it's interesting because we are going to discuss about that. We can see a very, very long trace here about the request that it is performed from the UI to populate this data. And why? It's because if we go here to our backend for frontend, and we open the specific endpoint that it is requesting all the data from the Films API and the Actors API, we can see that there is some very ugly implementation here, not performant at all, where we can see that we are first retrieving all the films, okay, but then we are iterating through all the different actors that we have in every film and retrieving it one by one. Okay, so it's a really, really old implementation. Don't do this in production, but it is interesting enough to evaluate a bit in an easy way the performance that we can have here. Okay, so we can see that we have all our data in around 1 second. Okay, we will inspect it a bit further later on. Okay, so let's try to start adding gRPC support here as well. Okay, so let's stop that, and the first thing that we have to do is let's take advantage of the different shared packages that we have here, the one for actors and the one for films, for defining our contracts, exactly the same that we were doing with our model. So we will do exactly the same here. Let's go here, let's create one folder called Protos, and let's add one element here. This is the Films API, so films.proto. Okay, and this is the file where we are going to define our contract for that specific API. Let's start. So the first thing that we have to specify in a proto file is the syntax that we are going to be using. In fact, is the version. Let's say we need to specify syntax, and we will be using the third version. Okay, cool. Then we need to specify an option. I'm going to explain what does it mean, but at the end, something that I haven't explained is that .NET, the gRPC version of .NET, is extensively using code generators. Okay, so at the end, it's just reading that specific proto buff and creating all the different all the code that we require for that specific communication behind the scenes. Okay, and here we are defining specifically the namespace that we want to have when it's generating such definitions. Okay, so sorry, .NET Barcelona films. Okay, then we're going to read the name of the package. This is the package films gRPC. Let's put it in plural. And now we can start defining services and models. Okay, so let's just create a service definition called films. And by defining a specific service, we start just typing RPC. We're going to focus our effort first in migrating the UI request for populating the grid. So get all here. We need some messages as well, because otherwise we can't define the entire service here. So let's create one specific film model message. Again, I did not need it here. Let me remove that, because otherwise we are not going to have help here from IntelliSense. Okay, and let's try to first check what we have. What we have already here. Let's put it in parallel here, and we can see that the film DTO is having an ID. So we define an ID by using int32, and you will see that when we're defining models here in grpc, we are always specifying a specific number. This is not that ID by default is 1. It means that it's having the first position in that specific string for defining that model. Okay, so it's mandatory to specify the position, and it's used then for the serialization and the serialization. Okay, then we have a name, so we have a name, position 2, then we have another string, because dates is something very complex to handle. So at the end, the easiest way to handle is just by translating as a string, and this is something that we are going to be doing today as a sample. Another interesting thing that we can see here is that we have an array of enums, and if you have a look on the documentation, you will see that in fact for the protobuf definition, we have a way of defining a specific enum, but it's always 0 based, and depending on how you're defining your enums, it might be you might have one problem with that. It might collide in that case. So the easiest way again to handle this is just by specifying an integer in that case, because it's the easiest way to do it. Categories, but here we are not defining a specific integer, it's an array of integers. And the way to define collections in grpc is by using the keyword repeated at the beginning. And this means that it's going to create a collection for that specific property. Okay? Let's just copy paste here, and at the cast is exactly the same here. And now we also need some message definitions for the request and the response. Meaning that at the end, this is following a pattern, a very simple pattern that most of you will know, called request response pattern. And in that case, we have to define both messages. So we can define here a get all request and a get all response object. Okay, and here we can define specifically that we are going to send a repeated film model, and we are going to call this films in the position 1. Okay, now we can define our service, sorry, that we didn't do at the beginning. Films, oops, grpc get all, and it's requesting, better said, sorry, I get all request, and it returns I get all response. And this is our first contract definition in grpc. We are defining our service. You can define more than one, of course, but we are just defining one here. Our model and a couple of objects for the response and the request. Okay, in fact, this is not like this. Sorry. Luckily, we have seen before compiling that. Okay, you might think, why I'm defining an object here empty? In fact, by default, Google is also providing some specific protobuf objects by default, so you can define an empty object here by importing that specific proto file. But at the end, it's more tedious and less verbose. In that case, it's more clear to have this specific object without any kind of information. And in the case in the future, you need to add more thing here, because who knows, we are going to add pagination or whatever here, so you can just extend the properties that are required here, and you don't have to redefine your services here. Okay, cool. What else then we need here? Okay, so nothing more in the shared part. So now we have to move to the API side, and what we need here is to install one specific package. close this. There is one package core, grpc-dotnet core is here. Let's install it. And this is a meta package that at the end, as you can see here in the right side, it's already installed in the client factory, the protobuf file. This is the one that it is handling everything behind the scenes, like the serialization, and so on, and some specific predefined protobuf messages, sorry, and the grpc tool. Okay, so everything that we require to have everything running in the server. Now that we have here our package, let's save this. I'm going to close everything. Save it, why not? Because it's already including this, so it is not needed. Sorry. Okay, go here. We need to go here and add in the server application, we need to add a reference to the specific protobuf file. So for that case, we need to define a new item group. And here we are going to reference our protobuf include, and since we are in the same root, we only have to go one level up in this package, and now protos films.prot. Okay, and we also have to specify which specific flavor do we need here. Okay, so we need to specify that we are in the server side and not in the client side, because of course then we will need a way to consume that specific service, and we will do exactly the same in our backend for frontend, but the code generated that we would like to have will be the client one instead. Okay, so now our server, it's listening, or it's taking into consideration that protofile to generate some code for us behind the scenes. Okay, there's nothing else that you need to at least take this into consideration. So what do we need to do now? So we can start defining our services or implementing our services, that it is the thing that we mainly need. So let's try to create a service, films grpc service. Okay, and now we should be able to films. Okay, what is not taking this in? Let me check 1 second. It is because it is not properly going back to the name is here, correct, protos is correct. Let me just comment this 1 second, let me compile it. Already by field categories. Okay, that's the problem. Okay, look at that. You can't define, of course, two different you can't define the same position for two different properties. Of course, it's a problem. It was not properly compiling, and that's why it was not creating the code for me behind the scenes. Now it's succeed. If we go here and we uncomment that, films dot, oh my god, 1 2 3 4 5, this is correct, but you already compiled. Come on, why are you still saying that? One fail, and we compile again. One more time. It's really annoying when it happens these kind of things. Build 1 succeed, 0 failed. Still the error here, not sure why. Protobuf is correct. Okay, let's try again here. Come on, let's try to then do the classic restart Visual Studio, because otherwise it has no sense at all what it is happening. So let me open again. it's opening. It's really annoying because, yeah, at the end you were seeing that the compilation was properly finishing, but for any reason that I don't know, it was not generating the code behind the scenes. So let's check now if we have the same error or something different. If we go here, okay, 0 errors. Let's try to comment that, compile again, just to check that now I no longer have the error that I was seeing before. Everything is compiling. Okay, nothing in the error. And comment films base. Okay, so the assumption was correct. Now I can breathe a bit because I don't know why this time to time happens. If you're having, this is something really annoying. I don't know what's happening behind the scenes with the tooling of gRPC, but if you make a mistake with the proto file, sometimes it's getting stuck for any annoying reason, and you have to restart Visual Studio in that case if you're working with Visual Studio. I haven't tested with Visual Studio Code or Rider, but at least with Visual Studio you might have this kind of problems. Okay, now we can start overriding the services that we have defined there. Okay, so we can define exactly that specific method, and of course what do we need here? So we need our DB context. We are in the film service, so we need the DB context here. Okay, I'd like to have the underscore here. Let's try to generate the constructor. So now we have everything here. We can start defining what we need here. So we need the films. We go here to the DB context, to films dot, and we can say, oh, we don't need it in that case. We only need to select because we need all of them in that case for the use case that we have. And we need to generate a get, not only a get real response. This is having where was the name of the object? Let's go here. It was film model. Okay. So we need to generate a film model. Okay. Oh, ID, name, release date equals to x dot release date to string, something very simple. And here we are going to find some specific troubles because by default these collections that gRPC is creating behind the scenes, sorry, are read-only collections, so we can't directly assign here our elements. So what can we do here? So first of all, let's try to isolate this generation to an extension method because we already had one thing here. So we have here our films extension. Let's try to make it public static film model to gRPC model. I'm going to receive a film here, an entity, and let's move that logic here. Okay, more film. Okay, let's copy this X first, and now entity again. A simple way to rename more things at the same time. And now, since these collections at least allow to add elements, not to override the property, but yes to add elements, so we can say film.categories equals entity.categories.select, and X is an enum. If I don't, yeah, it's an enum, so we have to cast it here to an integer, to list. Oh, sorry, I'm doing exactly the opposite that I said before. Add range, now it's correct. Okay, now it works. And film.cast this is more simple, we can directly add the range as it is. So entity dot cast, and that's all. And now we only have to return our film. Okay, so that's even better than before. So we can just invoke our extension method, and now we have here our films. Okay, cool. Then we can just say, okay, we have our get all, oh sorry, response equals to new get all response. We have our object that we are going to be returning back here defined, and we have to exactly do the same than before. Response.films.addRange, because we can't directly assign the property here. So we are just adding all the range, the entire range to the films array here. And now we can just say return response. Since this is a task, so we can say task.fromResult. A simple way to do it, and that's all. Okay, so now we have our service defined. We also have defined, of course, our proto file before, but we need more things, of course, to make this work, because we haven't registered everything in our program CS. So let's go here. First thing that we need is to say builder.services.add grpc. Great. And another thing that we need here is to define or to map our service. Map grpc service, films grpc service, and that's correct. But we need another thing. If you remember from the presentation, from the initial part of the presentation, we are using HTTP2 to use in gRPC. So by default, HTTP2 is not activated in the Kestrel. So we need to go here, and we have to define a specific property. It's very simple because IntelliSense is helping us a lot. So we have to use this specific protocol. Okay, so it's already doing all the work for us. So here we are saying to Kestrel that by default we are going to enable HTTP2 and HTTP1. Of course, if the API that you're exposing only have gRPC services, you can opt by just exposing HTTP2 in that case. But since we are also migrating from an existing API that is using or exposing REST endpoints, then we can just enable both of them, and we can keep this retrocompatibility while we are migrating from a REST service to a gRPC-based communication. Okay. Now everything should work because we have prepared everything. Let's try to run it, and let's see the first steps that we have to do if we want to consume, at least from testing purposes, this API. And for that, we are going to use Postman. Okay, this is running. Let's quickly check at least. We know that we are not using it anyway, but let's see that we haven't break anything. Cool, it's working. And if we go here to Postman, you know that at the end, Postman is not only having support for HTTP calls, has support for more other technologies such as GraphQL and gRPC as well. And what do we need here? So the first thing that we need is the base URL. So we can go here, and we know that our Films Web API has this specific URL. We can go here. Our recommendation is to remove the protocol here because it's going to use it by default, and at the same time we are going to see that later on by using reflection, if you don't remove that, it will not work. So yeah, we are pointing to the right method, to the right base URL, sorry, and then we have to import the protobuf file, because otherwise we are not going to understand the contract. So in that case, we go here to the shared folder, Okay, import as API, create a new API, films API. Okay. Now, if we try to select or check the different methods that we have in this contract, we can see that we have it. Okay, so it's properly understanding the protocol file and saying, okay, so you have a get all method here that you can invoke. Let's try to check by adding a breakpoint here if everything is hit as we expect. So we invoke here, and cool, yeah, it's hit. We can see that everything is working, so it's having by default dependency injection support, everything that you might have in other different services, or you will expect in different services, and it's perfectly working without any kind of problem. Great, we have our data here. Everything in that specific films array, we have all the data. But this is really tedious, because if you want to add new methods, or you are developing everything, so you will find a bit annoying, because you have to upload every time that you make a change in the protobuf file. You'll have to update properly in Postman. So how can we avoid that? Luckily, there's a specific Nugget package and a specific feature from gRPC called gRPC server reflection. Okay, and how can we use it? So we are going to be here in our API. Let's try to find for server gRPC, sorry, core server, and it was reflection. This one, great. Let's install this one. Okay, install everything. And if we now go to the program, something that it really annoys me a bit is the fact that if you have a look on how they implemented the gRPC extension method, it's created on a specific builder, something that I really like, because when you have like a family of assemblies for similar purpose, let's say, so you can have a nice fluent syntax here, defining all the requirements that you need for that. But in that case, for some annoying reason, if you want to add gRPC reflection, gRPC reflection, this is not taking into consideration the iGRPC server builder. It's just using the default service collection. Nothing really bad, but yeah, might be better if you have something like this. Okay, anyway, this is the way to do it, so nothing really bad. And another thing that we need, and we can use exactly the same approach that we will use for Swagger or something like that. We don't want to expose such services that at the end are just allowing us to discover everything in our API in terms of contracts. So we can do exactly the same here for gRPC. There's an endpoint and a specific service, let's say not an endpoint. There's a specific service that at the end, its only purpose is to expose a specific endpoint that it will show to everyone the specific contract that we have in that specific API. So don't expose this in production. Very useful to do it in testing environments, exactly the same approach that we follow with OpenAPI, Swagger, and so on and so forth. So yeah, let's check it. With that is enough, these 3 actions. Let's see if now, oh sorry, because if we don't do a change here, we are not going to see how it's working. So let's just define a new service here called get all 2. Nothing really fancy, but enough to check that it is properly working, the gRPC reflection. Okay, we have everything up and running. Now if we go here to Postman, we will be able to see that we have this nice button here. If we click on using server reflection, now you can see that you have enabled, so every change that you made now there will be reflected here. And now we can see that there's another method here, get all 2. We haven't updated manually, it has retrieved everything from this endpoint, and now we can have a better experience from local environment. Cool, let's remove that. Now it's time for the most boring part of the session. So we have to do exactly the same for actors. So let's go here. First define a proto here, protos, actors. That I'm going to do it as fast as possible. Also by copying and pasting, because yeah, we all do that. Actors grpc. This is actor service. Get all. We don't need the get all. We need get by ID. And this is get by ID request, get by ID response, because if we remember, we had this very ugly implementation here in our backend for frontend. We are going to use exactly the same. We want to match the same implementation, the same way between gRPC and REST. And if we remember, we were only requesting actors one by one. Okay, so let's go here again. Let's try to compare what we have in our previous contract. It's most simple. So we only have an ID, a name, and a date. So we can remove this. We can define here actor model, and this is what we are going to expose here. Actors. Yeah, this is not release date, it's date of birth. Something that I haven't mentioned is that by default, the preferred convention in gRPC when you're defining your protobuf is this snake case. Okay, so I think it also works if you use camel case, but that's the default one by normally. And if you are just also using cross technologies in that case, it's preferable to use the same convention. Okay, ID, name, date of birth, get by ID request, by ID response. So now we can use it here. Okay, let's go here, do exactly the same. It will be very repetitive in that case. This is server. Here we have it. Oh, this is not. Wasn't gRPC's server? What was the name? Let's check it from here. Otherwise, ISP.core. Sorry, my bad. Let's go here. We need exactly the same. Let's also copy that. We will be just changing it. This is not films anymore. This is actors shared. Protos actors.proto. We need a gRPC flavor, server flavor, sorry. Great. Okay, now we can say services actors gRPC service. We are doing exactly the same steps that we have done before. Actors dot actor base, great. Now we haven't had the problem that we faced before. Override, get by ID, same stuff, private, read only, actors, db context, actors, db context. Let's create the constructor, injecting it, and now we can do exactly the same here. So bar actor equals actor db context. Let me drink a bit of water, I'm thirsty. And find the sync of actors, find the sync by the request that I didn't specify the ID here, right? So let me go here in the proto file. Of course, we need to specify a specific integer here, the ID that we want to retrieve back. Okay. I hope that we haven't the same problem than before, otherwise it will be really annoying to restart again everything. Shouldn't be the case that much, so let's check now. Great, now it has. Now we have the actor here. Wait, sync, sync, perfect. And response equals divided by the response. In fact, I think that we can directly, because this is not a collection, so we can directly return it. And the actors, it is not actors. I kept in plural, yeah. Actor equals actor. And now what is complaining about? Same stuff than before, right? That's really annoying sometimes. It's something that I don't like so much about code generators. Actor model, great. Actor, that's correct. We go here just to compare it. Yeah. Okay, let's uncomment this, and response, it's still repeated field. Okay, oh my god, I left the repeated. This is not a repeated element, it's just a single one. Try to compile, please. Again. I think that unless it is a problem, a syntax problem in the definition of the protograph file, normally it will work. So yeah, we can see here that now it's taking the property properly, but of course this is not. We have to create also this same extension method that we have created before. So let's go here and let's create our extension model that will map our entity to a DDO. In this case, I think that we don't need that, so we can directly do it like in the method above. Actor model, and yeah, ID, name, date of birth. You can see that even though we are defining names in a snake case, then the code generator is changing it using the convention that we normally use in .NET, using camel case, okay? Higher camel case, upper camel case, sorry. So entity dot date of birth to string. Cool. Now we can go back here, import the method. We assume that will return always something. And cool, so we already have our server side up and running. What do we need now? So we need to go to our server side, or backend for frontend, sorry, and try to connect in the same way that we were doing against our REST APIs, but now against our gRPC services. And for that, and imagine that we are having a specific migration, so we will do something like a feature flag or something. So let's try to do something similar here. We are going to have a flag here called enable gRPC, and we are going to say that it is false by default. We are going to retrieve that at the beginning of the workflow here, but enable, or gRPC enabled, let us say, enabled. I'm going to retrieve it by the builder.configuration, and we can directly copy that here. And we have to parse it. Of course, I'm doing something very optimistic every place, but of course, this is just a demo purposes, so nothing that you will have to do in production like this. And we will use that specific flag here to do something if we have this implementation enabled. Otherwise we will contact targeting our initial REST API. And what do we need for having the client side here working? Because yeah, now we only have created a kind of feature flag, but we are not doing anything, so we also need some packages here. Unfortunately, we don't have a meta package like in the server side, so we have to install a couple of packages. So one is the grpc-dotnet client. Where am I writing? grpc-dotnet client. Okay, here we have it. And the other one you already have seen before, that it's automatically installed with the meta package, and we need it everywhere, is the tools package. Okay, cool. Install, apply. Great, now we have both packages installed here, and we need to import in the same way that we were doing before. We need to not import, reference, better said, the protocol files, and in that case we need it for both, for actors and films. So let's go here. I'm going to copy it. Here, replace that one. Okay, so now we are pointing to both proto files, but with, as I said before, now we don't want the source generator to create some server stuff for us. We need the client side, so we need to specify that here, and just try to compile everything and see if it's working. Oh, it will not work because of that, so let me just comment this out quickly. Build is started. Okay, cool, everything is compiled. Now let's uncomment this again, and let's try to implement the client side for our backend for frontend to contact with both services and deliver the data from the gRPC service. Okay, so the first thing that we need is to create a channel. And for this we need gRPC channel, this one, for address. And you might say, where am I retrieving that address? So we already have our address here. It's exactly the same that we have for the HTTP client, so we can have exactly the same, but it's disposable. It's a disposable thing, so we have to dispose here. Exactly the same for actors. Actors, where is it? Actors API URL. So here we have it. And now we need a client from that specific channel. Films client equals new films. This is the automatically generated code, or should be at least. Films dot client films channel. Okay. Films client. What the hell? New films. Ah, here. Sorry, we were missing the import. Okay, it was pointed to a different namespace. Same for actors. Actors. Oh. Perfect. And now we can start retrieving our data back from our gRPC services. So first thing, films response equals films client dot get all async, and we need to specify the request that we want to we request for that. Get all request and await it. Okay, this is returning back this get all response object for us with all the films within that object. And then we can use exactly the same approach that we have followed here for this ugly implementation, but we are going to do exactly the same ugly implementation because we want to compare it exactly the same. Of course, it's not the same object because this is the contract that it is exposed from the REST API, and this is the one that it is exposed from the gRPC service. Okay. Okay. Let's try to iterate over. Oh, it was already perfect. It is an actor. I need the actor ID, in fact, not the actor. In the films response dot films dot select many, as ugly as it seems, cast. Great. So now we have an actor ID here, perfect, and we can do exactly the same that we were doing before for retrieving the actor. Actor response, sorry, because remember that the object is containing a specific object. The response object is containing a specific object with the actor in that case, or the films in the other, like this one. So actors client dot get by ID, new get by ID request, where the ID is actor ID. Okay, great. We can use the async specific method, await, and add it to that specific actor response to the specific collection. Actor, great. What do we need? So last thing, we are finishing. In fact, we are going to copy that one directly and adapt it a bit. So for film response dot films not helping me a lot. Anyway, okay, this is working exactly the same. This will not be working because am I missing something here, because it's not helping any ambiguous reference. Actors, gRPC client, it's having an ambiguous but why it's an ambiguity now? Okay, anyway, let's try to specify directly the entire namespace, that it is this one. Okay, now shouldn't be a problem. I don't know why it's complaining now, but anyway. Okay, release year dot, in that case it is a string, and we have to parse. So date time dot parse this, and we only need the year because in that specific object we were just showing up the year release and not the type date. And for the rest of the things we can use exactly the same. In any case, I think this is, since this is an integer, we have to do a weird cast here. So this is a film category, and now we can just say to string. Now yes, this is not very nice, but should work. And now we are ready to use our API. Okay, since that, I don't know why before I did an extra import that was not necessary. That was the reason why it was complaining here. Now it's not longer needed. Okay, so let's try to execute everything and see, first of all, if it's working without grpc enabled. Okay. Okay, up and running. If we hit our endpoint, I think in fact we forgot something. Now I'm remembering that we haven't registered here. Sorry. Let's do it quickly because we haven't changed the Kestrel here. Let's copy and paste everything here. Okay, and the program, I'm not going to use grpc transcoding here, I don't need it, but I need to specify app the grpc endpoint, otherwise it will not be able to connect. So map grpc service actors grpc service, great. And now I think it should work. In any case, since we were not targeting initially because of the feature flag that we were adding, it will not crash, but once we change it, of course, it was something that we were missing. Okay, so let's check now. Okay, it's still working, so we are in the phase of migration, and even though everything seems to work, and now it will be time to check something. So this, if we go here to the traces, we can see that, yeah, we have here one call when we were populating initially the grid. It's taking a lot because of the ugly implementation, because it also has to warm up everything. So it's the initial request. Let's forget that specific one. Let's try to refresh 3 times more and see the time that it takes to retrieve this data. Okay, so we can see that, yeah, we have this initial one. We don't want to check that too much, but the second one took 1.5 seconds, the second one around 1 second, and the last one in between 1 second and 1.5 seconds. Let's stop now this, and let's try to switch to grpc, and likely we will have everything working from the beginning, likely. Let's see if that's the case. Now we have enabled that. Of course, it's something that I haven't said before, but yeah, this is demo purposes, but normally you will have this kind of flags and configurations using an options pattern or something similar. Don't forget that, even though we are doing it or taking advantage of this easy implementation mechanism by having everything defined in the program, but of course for our production ready application this should not be the case. Let's go here, let's open our UI, and this is loading, and okay, it's hitting the breakpoint that we left before. Actor response unimplemented. Why it's in unimplemented? We already defined, right? It's here, and it's registered here. App.actors grpc service is exactly the same that we have here. Great. And we already have added the service at grpc, right? Did I forget that? No, it's there. Why it's failing? What did I forgot? The Kestrel was done. Everything was there. Should work. Get by ID. Let me go here to the program of the backend for front. Oh, it's here. You're using get by ID async. Yeah. Okay. grpc unimplemented. That's quite annoying. Okay, that's why. That's the reason why. Of course, in this specific channel, in the films channel, I'm not going to find any kind of actor. Okay, now it's properly using the channel, the appropriate channel. Let's run it again. Luckily enough, we're finding several troubles, but we are getting over all of them. That's good. Let's try it again. Open that. And now, yes, now it is working as we expect. And look at that, we can go here, go to the traces, and we can see that we have one single request here, of course with all the different details from this ugly implementation behind the scenes. But you can see that now we are no longer using our get actions. So now we're pointing to our gRPC services in both things, from the films one and from the actors one. It might be a bit small for you. Let me just do a bit of zoom here. We are just pointing to both gRPC services, okay? And we are going to do exactly the same than before. Let's try to not take into consideration the first request, because exactly the same that you will have with REST APIs, so it has to be warmed. So let's try to request 3 more times. And now, if we go here, okay, this was the first one, it took less than 2 seconds. And this really old implementation, exactly the same approach in the really bad manner, we can see that in the first request, it took a bit more than half a second. The second one, less than half a second. And the last one, even less than 400 milliseconds. Of course, we have to take these numbers with a pinch of salt, are not something that you have to take for granted, and in every kind of scenario you'll have better performance using gRPC. You have to carefully take into consideration your requirements and everything. But it's a nice real case where we can just compare everything between both scenarios, and we can see that at least in that case we are having more than half. We are having the same amount of data in half of the time. Sorry. Okay. So this is really interesting. Okay, so now that we have everything worked, of course we are not going to be there for seeing how I have or how I will be coding everything. So let me just stash everything, and I'm going to change my branch to a specific one that I already had with everything already implemented. And which specific nuances I will say about that. So you can see that I have followed the same approach that we have been coding during these last 40 minutes or so. I already have this specific flag here. All the endpoints are just splitted between gRPC and REST. Some details, you will see that when you're following this kind of practice, you'll have to properly name very specific all your specific objects, because otherwise it will collide. For instance, if you have one get all and another one get all the actors API, so might collide both of them. So in that case, you have to be very specific with the names. Otherwise, you will have a small problem, or you will have to differentiate properly between one namespace and the other. But you can see that we have implemented everything. So we have implemented the get actions, the register one, the delete one. Very simple to define. At the end, you're always following the same pattern, request response pattern. And if we go to the service here, something that I haven't explained before, but there's a specific way to treat or to handle exceptions or errors. So you might expect to have this kind of exception if you're working with gRPC services, especially if you're not coding the server side. So expect to have this kind of exceptions. At the end, you're having a very similar development experience than the one that you have when the code is already in your system, so you don't have this perception that you have when you're coding HTTP clients targeting on a specific API that you know that are not in your same let's say environment. In that case, you are going to receive an exception, and you can specify a specific status code here. So you can see that you have a lot of different options: cancel, data loss, fail precondition, internal, okay, not found, invalid, everything. You'll find a lot of different arguments here that you can use, flags, sorry, better said, for a RPC exception, and some data that you can add here. Okay? Okay, so let's try to run it a last time, now with all the different implementation details. And I didn't check, okay, gRPC is enabled then, so let's check how it works. It's up and running gradually. Okay, and let's see, did I add a breakpoint? No, okay, I don't want to interfere. Okay, it's loading, so let's try to paginate. Everything is working. Let's try to see the detail of one film. Great. Let's try to register one film. Test grpc. Who cares? Chris Hemsworth. Wait. Okay. Test grpc. It's here. Okay. Let's check here if it's properly added to the database. We don't trust it. So we have it here: films, databases, films, tables, films, view data. Great, we have it here. Let's try to delete it. On paper it has worked. Let's refresh, and now we no longer have this film, so everything is working with gRPC now, okay, with a very good performance. Of course, as I said during the presentation, you have to take everything with a pinch of salt. Depending on the requirements, you might need it or not. There are a ton of situations, and at the same time, there are a few steps missing to have a production-ready application working with gRPC. Of course, we haven't talked about authentication, authorization, error handling, and so on and so forth. And at the same time, we have discussed about several capabilities that gRPC allows, like the bidirectional streaming or single streaming, one-way streaming, sorry. There are specific use cases for that and are quite interesting to know about. Of course, there are a lot of things that you can check further after that, but these are the most important things that you will require. I think it's mostly covered, the specific requirements that you are going to have in your applications if you're migrating or thinking in the communications patterns that you have from REST API compared to gRPC. That's the thing that we try to target today, okay? But there's, before leaving, something that I will require 5 minutes more to show you. There's another interesting feature that I have explained during the presentation, and I want to show you how it works with a very simple implementation. And since we are running a bit out of time, instead of coding it, I will just directly change my branch and explain the different things that you have to do for implementing it. Ironically, we will be twisting a bit the scenario, because from the target that we had at the beginning, we tried to change an existing application with using HTTP-based communication to a gRPC-based one. But now we are twisting it a bit, and we are going to use JSON transcoding to expose existing gRPC services as REST APIs. Of course, in that specific use case, you will not need it. Of course, if you already have your endpoints clearly defined, properly working, you will not need that. But imagine that you are defining your API from scratch with gRPC, and in a certain moment you require to expose those services as REST actions, because there's a specific client that only can hit, because a certain reason, REST APIs. So what can you do with that? So there's a specific package called JSON transcoding. You can see it here. I don't know if I added here in the actors one. Yeah, there's this specific package, the JSON transcoding package, that you have to add it to the project. And there's a specific property that you also have to add it. Why? Because, let me show you. In the actors proto, we are defining a specific import. Okay, this annotations package. This annotations proto file, sorry. For import that, you also have to define here that you want to include these protos. Okay, otherwise it will not be able to understand what the hell are you adding here as an import. Okay, and this is allowing us to specify different options within a service. And in that case, you can see that we are adding a specific options, an HTTP option to that specific endpoint called actors transcoding. So meaning that this specific service will have a specific endpoint in that URL. Okay, there's something that you also have to know about that. There's a specific nuance if you want to share the same contracts with others. In that case, look at that, we are defining more things in that proto file. And the client side, that it is our backend for frontend, should also understand that. So if you want to use the same contract, you also have to do exactly the same steps in the client application. You also need the JSON transcoding, you also need this, and otherwise it will not be able to read it. Another option that you can do is just having separate contracts. And in the contract that you have in the server, so you define these options, and in the one that you have in the client side, you don't have it. It depends on your preferences, but this is the kind of concession that you need to have, or you need to do if you want to have the same contract in both sides. Let's try to run it once, and this will be the last time that we run anything here. Then I will give you a bit of time if you want to ask something. I will be reading the chat. So running it, we already know that this actors API that it's here, it's running in that particular endpoint. Let's copy. Let's go to Postman. Where is Postman? Another request. No, this is not gRPC. Okay. And if we go here and we copy directly the name of the endpoint, if we hit that, we can see that we have a twisted scenario. As I said at the beginning, we are exposing our REST services, our gRPC services as REST endpoints. Okay, and that's all. So of course you can deep dive on everything. You can further investigate about the different things that you have here. The target for today was to introduce gRPC, the capabilities that you have, a brief example of how you can improve the performance with that. There are more things that you can use from gRPC as we have explained. We can cover if you want in further events. But well, so it gives you a bit the initial understanding on how you can start using it in your production applications. And that's all. So I hope you have enjoyed it. Now it's time to reply some questions if you may have it. So I'm reading the chat. If you have some questions, I will be glad to reply them. If not, we can finish the session. Okay, I'm not seeing any question then. I'm going to wait 1 minute. Don't be shy, I will be replying your questions if you have it. Well, I think I forgot to mention something interesting. You might be wondering, because we have created a sample application here. There's no authentication, there's no authorization, but you might wonder how you can apply that. It's using exactly the same implementations, the same details that you are going to use in any other ASP.NET Core application. So you can use JOT token or whatever specific implementation that you need, that you have, sorry. You only have to go here to your service and say authorize, and do exactly the same that you will do with your controller. Okay, so this is something that is really interesting. We haven't talked about that, but in case you need it, so now you know it. Okay, so it seems that there is no question. So again, I hope you have enjoyed. In case you wanted to assist but you couldn't, so it will be uploaded to the .NET YouTube channel, and yes, so you can access from the web page as well. We will have more events in the future, so stay tuned. And yeah, thank you for coming. Thank you, Eljo. Thank you, everyone. Bye bye.